Okay, so part two in the beginning, we're looking at aspects of emotion. We've been talking about Ekman's facial action coding system, right? And we're going to see some modern day applications of this. And researchers at the Ohio State University have found a way for computers to recognize 21 different facial expressions, even expressions for complex or seemingly contradictory emotions. The study gives cognitive scientists more tools to study the origins of emotion in the brain. Here, a study participant makes 3 faces. Can you get them? Well, we got happy and disgusted, pretty easy to pin down as the first 2, but when we go all the way over to the left-hand side, what do we see? We see a blended or complex emotion, if you will, called happily disgusted. So these undergraduates in Alex Martinez's lab at Ohio State then are trained to make these expressions. They use Ekman's facial action coding system, but what we're really talking about here is Martinez, and there he is an associate professor in the Department of Electrical Computer Engineering at Ohio State, right? Where he's the founder and director of Computational Biology and Cognitive Science Lab. He is teaching computers to recognize these facial expressions. That's what his lab does. You can imagine where that's going to go as we get increasingly immersed in our interaction with robotics, with artificial intelligence. Then we might have the potential for Alexa. Let's say, Alexa, looks at you in the morning, not just listens to you, but looks at you and looks at your face and then does the facial action coding and says, oh, what's going on, Mark? You look a little sad today. Is there something I can get you to kind of improve your mood? Now, whether we want to interact with IA or robots in this fashion, that's a whole nother issue, but developing the capacity, as we can think, might be useful in certain contexts. So, and Alex's Martinez's own word here, we've gone beyond facial expressions for simple emotions like happy or sad. We found a strong consistency in how people move their facial muscles to express 21 categories of emotions. A cognitive scientist, he's associate professor of electrical and computer engineering at, and they never put the in there, so I got it in there, the Ohio State University. That is simply stunning. This tells us these 21 emotions are expressed in the same way by nearly everyone, at least in our culture. Notice this is where he's deviating from Ekman, because Ekman was looking for what we can recognize across cultures. Now we're kind of caveating within culture. Fascinating thing, when I did my dissertation on non-conscious emotions, I've got 3 people from psychology sitting on the dissertation committee for my dissertation meeting, and then they have to have a 4th person who is not from your department, somewhere else in the university, and people volunteer, and that's randomly assigned to you based on availability. Of all the people in Ohio State to sit on my dissertation on non-conscious emotions, who did I draw? Frickin' Alex Martinez. Oh my God, as a motion engineering guy, it was cool. It was just the greatest experience ever. I do count myself as one of a very lucky person on this planet, and good luck has smiled upon me many times in my life. So, and I believe that was one of them too, because it just made the dissertation defense kind of a party. It was just really cordial and a lot of fun. So, and I hope for those of you who eventually go on to do that, you have the same similarity of experience. So we've talked the biological. Let's go on to the cognitive bases, these cognitively based theories, right? And here's one of the leading kind of ideas, is the Circumplex Model. I don't know who to attribute this to necessarily. I think it was a lot of people kind of contributed to this over time. And what we look at here is a model that demonstrates basic emotions. And you say, well, we already got models that demonstrate basic emotions. What's the big deal? It's like, well, the Circumplex Model has some nice features. The basic emotions are arrayed in the center ring here, right? And we see, let's go through it. Anger, that was one of Ekman's. Disgust was one of Ekman's. Hey, sadness was one of Ekman's. Surprise was one of Ekman's. Fear was one of Ekman's. And joy, happiness, was one of Ekman's. So of the 8 basic portrayed in here, 6 agree with Ekman. But what's different? Well, notice, anticipation and trust are 2 basic emotions according to the cognitively based circumplex model that Ekman didn't include in his biologically based model. Right? So I find that fascinating, these differences. Now, what else does the circumplex model do for our understanding of emotion? Well, two things. First of all, it talks about emotion in terms of degree. So while we have anger as a basic emotion, rage would be anger on steroids, right? But annoyance would be kind of anger light, if you will. So it allows us to array different levels of emotional experience around a basic emotion. And then, really tricky, the circumplex model allows for blended emotions, and that's these little emotions that come around here, right? So, in this case, let's look at contempt, and remember contempt was Ekman's 7th basic. So, annoyance and, anger and disgust combine to make contempt. So, if we go back to my example of being in the bar and asking that woman if I could buy her a drink, and she gives me that contemptuous expression, and contempt is cool in that it's one of the few emotions that is asymmetric on the face. Contempt is signaled by raising one corner of the mouth, but the other remaining in a neutral position. So, contempt then, according to Circumplex, is a combination of anger and disgust. She's angry that I asked her and disgusted that I would even, approach her perhaps, and that then is the contemptuous expression. So there's a lot to be said for this model, and a lot of people are supporters of this model of emotion. And this, of course, is when I say questions, right? So, let's talk another theory then, a cognitive theory, differential emotions theory. 10 emotions constitute the principal motivation system for human beings, and that's why I'm talking about DET here rather than another, because it really is kind of first and foremost has a motivational flavor. 10 emotions constitute principal motivations for human beings. Second, unique feeling. Each emotion has its own unique subjective phenomenological qualities so that we can readily identify our own experience and differentiate those experiences across the 10, hence part of the reason for their inclusion in this model. Each emotion has its own unique facial expressive pattern, according to the author, Izard. Each has its unique neural activity. So you can see how Izard is combining his list of basic emotions and supporting his contention that they should be considered basic. And 5, a unique purpose unique purpose or motivation. Each emotion generates distinctive motivational properties that serve adaptive functions. So let's take a look at Izard here. Say hello to Izard. Hi, how you doing? Notice he's got the facial expressions going there. 10 fundamental emotions, including in his DET theory. So positive emotions are interest and joy. So interest that leads to curiosity or exploratory behavior. Surprise is a neutral emotion. And then the negative emotions, fear, anger, disgust, distress, contempt, shame, and guilt, all as negative emotions, right? What's clear about Izard right off the bat is he likes to slice and dice emotional experience into positive versus negative emotions. And that's not the same for every emotion researcher or every emotion theorist. Some people kind of reject the positive negative emotional explanation as not very utilitarian. I am one of those people. I belong to a different camp. It's more the Frida camp, which is action tendencies are emotions linked to approach, avoidance, or freezing in one's track, which is much different than positive emotions or neutral emotions and negative emotions. One of the problems for example, when we look at approach emotions might be happiness and might also be anger. But that would be a positive versus and a negative emotion that both indicate approach. So it really depends on the perspective someone's taking and where they're trying to ultimately go with their conceptualization and their theory. There's not a single right answer, and this is one of the bitchin' things about studying emotion is it is kind of wide open. So the DET are arrayed across 2 dimensions that are important to Izard, and you can see how he picks up on these. That is the arousal pleasantness. So 2 dimensions. How pleasant is the emotion from negative to positive, right? and to what extent is it a low arousal versus a high arousal emotion. And notice that can be tied to the neural firing. So the number of emotions then, an excited pleasant, he catalogs 27. An emotion example, if I'm excited and it's a pleasant experience, then it would be euphoric. If it's neutral pleasant, then let's drop down a notch or two and call it appreciative. And then think about sitting in a very comfortable situation where you're happy to be there. Then you might be calm and pleasant and you're experiencing content. So Izzard makes a solid case for his theory, and that's not that one is wrong or one is right in terms of these theories. They just have different purposes. Now notice, excited, unpleasant, disgusted, neutral, unpleasant, right? Irritated, calm, unpleasant, bored. And then excited, neutral, calm, neutral, surprised, and at ease. So those are the two dimensions and the number of emotions listed on each with the emotion examples. So when we look at the DT in the environment, affordances and complexity, right? So what we're talking about then is on the top of the chart here you see anxiety laden versus anxiety free. So take that down the center point, right? Let's talk about a chaotic environment, and this is where the environment comes into evoking emotional states and the motivational qualities that those emotional states imply. Chaotic, the environment taxes real-time understanding, resists stable interpretation, or is indicative of insecurity. Right? So how many people think that the current pandemic really is kind of this chaotic situation? Right? It's high complexity, right? We are highly activated. Oh my God, what's going to happen to us? What's going to happen to our loved ones? What do I need to do in terms of basic action? Do I need to go hoard toilet paper, right? And then the unpleasantness, right? Because of the uncertainty. So we have high extrinsic motivation. We're motivated by external forces. How many of you before the pandemic said, man, I got to have a shitload of toilet paper or existence is going to end, right? But what we see in this case, when people are highly uncertain, right, they're in high activation and high unpleasantness, they're extrinsically motivated to do all kinds of wacky stuff like hoarding behaviors or what have you. Notice it can have a negative aspect too. When politicians are calling the coronavirus the Chinese virus, then we see people who are anxiety laden, right, who are uncertain, who think they're operating in actually attack Asian Americans as a result of this process. But that's also across the globe. I don't know if you saw the video of some girls attacking other Asian girls, and that was in Australia. But this is that high complexity, unpleasant, and high activation. Now in a boring environment, what are we talking about? Well, we already said it's unpleasant, but it was minimal activation. This is where an environment is low on affordances, that is, and affordances mean there isn't much to do, there aren't much motivating aspects of our environment. So an environment that is low in affordances is low in activating qualities or interesting qualities, if you will. Okay? Now let's go across here diagonally. You see that this is high complexity, up here is low complexity, and we see then low extrinsic motivation. Oh, I should have mentioned for low on affordances, low intrinsic motivation, right? But this is calm, right? So the environment is low in its complexity, nothing much going on, not a whole lot to worry about. It forms a stable, consistent, and harmonious whole with ample indication of safety. And then finally, let's go to kind of the pleasant activated. The environment is high on affordance. There's a lot to do, there's a lot to engage in. Imagine, like when I used to go to the festivals, I go to Electric Forest Festival, right? And I remember you hit the gate and it's like, oh my God, where are we going to go? What are we going to listen to? What are we going to go see? What are we going to do now, right? And it's lively. The environment provides many interesting aspects, right? Affordances without indicators of insecurity, because at festivals, you know, it's all fenced. Hey, there's security, everything's cool. Just have a good time, enjoy yourself, have a ball. And it's high intrinsic motivation. People are just like running in. People save their money to go, right, and spend it on this. Why? because they want to, because it's intrinsically motivating. So of all the folks, except maybe for action tendency folks, which probably are on an equal footing with Izzard and his DET, this is probably one of the best blendings of understanding the environment, understanding the person, and how emotional states interact with motivational states. This is probably #1 explanation in that regard. Questions about that? All right, I want to take on another biological here, which is facial feedback theory. Internal, external event, right, affects us through the neocortex. It alters the rate of neural firing. The limbic system, right, the hypothalamus, basal ganglia all respond to this, right. The impetus generated in motor cortex and sent to face. So this is how facial expressions are created via the reaction to the environment, changing the neural firing through the limbic system, sends messages to the motor cortex. The facial nerves, right, then are activated in the facial action, changes in facial musculature, changes in facial temperature, and changes in facial glands. Notice this temperature thing is often used now, or trying to be used, by security forces like in airports, with infrared cameras measuring facial temperature, identifying people who should have further scrutiny because maybe they're anxious, i.e. plotting to do something bad. Of course, how many of us are anxious just going to the airport and having to go through security in general? That's a whole aside, and most of that is informed by very little scientific knowledge. So, and then the facial nerves then respond. The receipt of facial action information in the sensory cortex. So this is where the facial feedback occurs. That is, now that the musculature has been changed, that musculature is monitored, and the brain then reads the changes, and it's the cortical integration of facial feedback information experience. What this kind of indicates is a two-way street, that biology informs the mind, and the mind forms the musculature, but then we monitor the musculature and reassess it. Famous study that is under scrutiny at this point in time. There's been some failures to replicate this, and maybe you've heard the term the replication crisis, especially in social psychology. Many studies are not replicating. Maybe we're not certain why they're not replicating. Many people are accusing scientists of fudging results or chasing p-values through minute modifications in the study until they achieve significance. I don't know what to say about that. I think different times then might cause failures in replication longitudinally. Hard to know. Hi, Proton. How you doing, sweetie? I'm glad you came to join us. So the facial feedback in the Strack, Martin, and Strepper study, super cool study. What they do is they bring participants in and they say, we want you to hold a pen in your mouth this way, right? Which causes then these muscles to be activated. And facial feedback theory, these people then report feeling sadder or more easily recall sad information because their brain is monitoring their own face and demonstrating that they must in fact feel sad because they wouldn't be making that facial expression otherwise. Fascinating idea. Here the pen then is put horizontally and it mimics a smile, and these participants then reported feeling happier as a result of this experiment. So interestingly, motivation and emotion don't just occur here in the brain. They are biological. They are experiences that are also involved bodily, sensation and bodily position, and a lot of work done in that area. Like Amy Cootie's power posing, that if you want to do well in an interview and you want to come off as confident before the interview, then you should erect your spine, stick your chest out, pull your stomach in, and say things like, I got this, you're going to kick ass, right? And this causes then the feedback which affects how we respond cognitively. Fascinating ideas, right? So, This then leads to just kind of an interesting point. So, should we just say no to Bo? Because what does Botox do? Botox is an interesting idea. First of all, what I'm going to do is inject a poison into my forehead that will freeze my muscles. Bless you, sweetie. You're getting very sneezy, huh? Yeah. Okay. So, what did they do in this study? Well, participants given Botox injections read sad sections of a story more slowly than control condition participants. The idea is pretty simple here, right? The peripheral feedback, that is the facial feedback, right, affects cognitive processing. So, you know, if I'm sad, then I tend to think and maybe furrow my brow, etc. And if that is interfered with, then my processing of sadness information then it is slowed down as a respect, in respect to normals. The cat's gonna just sneeze herself crazy here. So let's then go on. I think, oh yeah. Let's make this a new part, so let's return to cognitive aspects of emotion. I believe this will be, what, part 3 then. So, hang on.